Okay, so again, if we have a periodic table, this is for ionic bonding. So if we will have periodic table, so this one, so let us remember the oxidation number for the metal. So for this one nga side, sa hydrogen, lithium, sodium, potassium, and taman diri sa francium, positive 1 ang ilang mga oxidation number. For beryllium, magnesium, calcium, strontium, barium, and radium, positive 2. And then there is sa picas, the boron, aluminum, gallium, indium nga group, positive 3. Carbon, positive 4. The nitrogen, negative 3. Oxygen is negative 2. Ay, sorry. And then for fluorine is negative 1. So for the determination of replaceable, ang ato ang tanawon kay ang metal. Kaning naa sa tunga, kaning mga transition metal, depende kung pila na ilahang mga oxidation number. So ma-determine lang nato sila using the chemical formula nga given. Okay, so for example, if na ako NaCl, if na ako NaCl, if i-ask if how many, pila ang number of replaceable for NaCl. NaCl, if na remember, na siya sa first group. So we have positive 1. So pasabot, ang iyahang number of replaceable kay 1 equivalents per mole. Another example, if na ako'y barium chloride, so we have barium chloride. Kaning barium chloride na siya sa ikaduha, beryllium group. So this is 2 equivalents per mole. Another example, kaning calcium, 2 gihapon, and then aluminum is 3. So for example, if na ako'y aluminum chloride, so we have 3 na number of replaceable. 2 equivalents per mole. Again, tanaw na to ang iyahang oxidation number. This is true for ionic bonding. However, if we have kaning acid, so acid, we can directly count the number of replaceable H by just looking at sa iyahang chemical formula. So for example, if we have hydrochloric acid, H isa, and then kaning sulfuric acid kay H2 duha, number of replaceable H. And then for phosphoric acid, we have tulo, and then nitric acid isa. But if we have CH3COOH for acetic acid, the only replaceable H here kay kani. So for this one, 1 equivalents per mole lang na siya. Kani nga H, wala ni siya i-appeal sa ato ang replaceable H. Okay, for bases naman, so again, to distinguish bases, na siya mga OH. So for example, if we have sodium hydroxide, isa lang atong OH, so we have 1 equivalents per mole. And then barium hydroxide, we have kani duha. So 2 equivalents per mole. So that is how to count sa ato ang mga number of replaceable. Okay, so for acid-base reaction, 1 equivalent of an acid daw reacts with 1 equivalent of the base. And for an acid, HCl, so if we have HCl here and NaOH, pasabot, need na ko og isa ka OH para ma-neutralize din akong H ni HCl. Pero if na ako'y H2SO4, dahil iyang partner kay NaOH, it means kailangan nako og duha ka NaOH, duha ka OH para ma-neutralize po din akong duha ka H plus na H2SO4. Okay, so let us try this one, the number of replaceable H or hydrogen or replaceable OH or hydroxide. So HCl isa, dayon CH3COOH isa gihapon, H2SO4 duha, H3PO4 tulo, kani KOH isa, kani duha, kani isa. Kani, this is ionic bonding. So this is ionic bonding. So si K kay naa siya sa first group. So ana ta ang mga first group kay positive 1. So si K diri kay positive 1. However, for the chemical formula, naa siya duha ka K. So we have positive 1 times 2 kay duha ato ang K diri. So ang ato ang number of replaceable diri is 2 equivalents per mole. And then for calcium, this is directly 2 equivalents per mole. And then for sodium, sodium again is positive 1. However, kaning sodium carbonate kay duha man kabuk yang sodium. So positive 1 times 2 is equals 2 equivalents per mole. Example, if na ako if na ako problem nga mag-ask og how many replaceable H ang naa sa 2 moles? 2 moles of example kani K2CO3. So pila daw ang iyahang number of replaceable H? So to count, di ba ana ta ang K kay naay positive 1. So we have positive 1 times 2 natay duha equivalents per mole. Pero naata diri duha ka mole. So multiply again to 2 is equals 4. So pasabot sa 2 moles of potassium carbonate naatay 4 equivalents. 4 equivalents na siya. 2 pala. Tama. 2 equivalents. So again, base na yung mga problems na usually gina-ask ang mga number of replaceable. Sorry. Okay, so equivalent weight. So the equivalent weight is the mass of the element or a compound that will combine with or replace 1 mole of hydrogen. So it is dependent on the total charge of a positive ion or the valence of the element. So the valence of the element kay pwede po siya katong replaceable number of H or OH. Okay, so let us try this one. So we will determine kung pila ang iyahang number of replaceable. So number of replaceable for NaCl isa 1 equivalent per mole. For barium, di ba ana taganiha 2. Again, this is ionic bonding. For ionic bonding, oxidation number of the metal. Kani ato ana ning na solve potassium carbonate, we have plus 1 nga potassium times 2 kay duha man ni. Asa nagikan ang plus 1 sa oxidation number? Equals 2 equivalents per mole. Calcium 2 equivalents per mole, aluminum 3 equivalents per mole. Fe, kaning Fe, so if di ba if ma-remember nato ang how to write chemical formula. So di ba we use the crisscross para maghimo ta og chemical formula. So for this one, pasabot kaning 3 diri kay charge na ni Fe. So if atoan ang bulagon, makahimo ta og Fe 3 plus og SO4 2 negative. So ana man kaya ta nga si Fe kay 3 plus, so we have 3 plus nga charge times duha siya ka buok 6. So iyahang number of replaceable is pila ka iron duha. And then to determine the number of replaceable, 3 times 2 6 equivalents per mole. So to calculate the EW, so ato ara na siyang iyan no. For NaCl 58 iyang molar mass divide 1 equivalents per mole, gram per mole. We have 58 gram per equivalents. Kani BeCl, then the rest kamo na bahala na. Okay, so now we will calculate the normality. So sample problem 1, what is the normality of a solution with 0.587 gram of NaOH having a molar mass of 40 gram per mole in a 25.7 ml? Again, to calculate normality, use the formula N is equals the mass divide the molar mass over the number of replaceable H or OH divide the volume of solution or liters. So the normality, pila ang mass? 0.587 grams. Molarity, 40.0 gram per mole. Divide ang equivalence of NaOH, OH this is a base, isa, 1 equivalents per mole. And then, liters of solution, we have 25.7 ml. Convert na to siya to liters. So, we have 1,000 ml, 1 liters. So, calculate using your calculator. Ato ang makalculate ani is 0.571 equivalents per liter. Cancel out the gram, mole, cancel out. Mabilang tag equivalents. Dari sa ubos, cancel out the ml. So, for normality, units used kay equivalents per liter. Okay. Next, so what is the normality of a solution that contains 150 grams of a sodium chloride per liter? So, for this one, we will use the formula. By the way, kani gali siya nga formula. Kani siya. We can derive this one as normality is equals mass or weight of solute. Itong same gali sa ato ang normality, molarity o molality. Divide EW times liter of solution. So, it's either kani, inyong gamiton nga formula, or kani, same ra na siya og answer. Okay, so for this one, we will use katong ikaduha. So, we have N is equals weight of solute divide the EW times the volume of solution in liters. So, normality is equals 150 gram of NaCl weight of solute divide the EW. Ang EW na to for this one, sodium chloride is 58 ang iyang molar mass. Diba? EW, remember, EW is equals molar mass or molar weight divide the number of replaceable H or OH. So 58 gram per mole divide 1 equivalents per mole times the liter. Pila ang liter ani? Nara. 1 liter. So, normality here is 2.59 equivalents per liter. So, if inyong gamiton nga formula kay katong isa, katong mass divide molar mass over the number of replaceable over the liters, same ra gyapon siya answer. 150 grams NaCl divide 58 gram per mole divide 1 equivalents per mole over 1 liter. Same ra gyapon na siya answer, 2.59 equivalents per liter. So, pwede nga kani inyong gamiton, pwede pod kani inyong gamiton. Depende lang kung unsa ang mas comfortable mo i-use nga formula. Okay. Another example, how do you make 500 ml of a 2 normality NaCl. So, use the formula, normality again. So, normality is equals weight of solute. So, diri, how to make yang giingon. So, wala ta niya gitagaan og weight of solute. Pila daw ka weight of solute ang atong ibutang sa 500 ml para makahimo ta og 2 normal NaCl. So, weight of solute, weight of solute, EW times the liter. So, we have normality here nga 2. Normality equivalents per liter is equals weight of solute, mao atong isolve, divide EW. Again, EW can be calculated using the formula molar mass divide the number of replaceable H or OH. So here we have EW. NaCl is 50. Sorry. So NaCl is 58 over So 58 gram per mole. Giyon sa nato pagkuha ang 58 molar mass of the NaCl, we have Na nga 23 plus Cl nga 35. So 58 gram per mole ni siya. Nigikan sa periodic table divide 1. So since NaCl kay isa raman iyang number of replaceable. Times the liter, pila? 500. So 500 ml convert to liter, this is 0.5 liters. 0.5 liters. So weight of solute is equals to equivalents per liter times 58 gram per mole. Atoan na lang ni siyang simplify. This is gram, mole. This is gram per equivalents times 0.5 liters. Okay. Cancel out liters, cancel out equivalents. Ang nabilin sa twice gram. The weight of solute now is 58 gram of NaCl. So pasabot, need na to of 58 gram nga i-dissolve sa 500 ml para makahimo ta og 2 normal NaCl. Wait. Let us go back di. Ayan, tama. Okay, for this one, so we will calculate the barium chloride concentration in milliequivalents of a solution prepared by diluting 25 grams of barium chloride to 2 liters. So, milliequivalents, also normality ragya po na siya. So, use your formula. Normality is equals weight of solute divide the EW. EW again, molar mass, divide the number of replaceable. EW times liter of solution. We have here weight of solute 25.0 grams divide EW for barium chloride. We have barium chloride inani ihang chemical formula. So for barium chloride, ang atuang molar mass for this one is 137 plus duha ka Cl 35.45 times 2 we have 137.33. So using your calculator, calculate the molar mass. So 137.33 plus 35.45 times 2. Times 2 is equals pila? 208. 208.23 gram per mole. Okay, so AW again 208.23 gram per mole divide the number of replaceable pila for barium chloride. We have 2 equivalents per liter per mole. So 2 equivalents per mole times liter. Pila ang liter nga gihatag diri? 2 liters. Using your calculator, the answer for this one is 120. Wait. Dili ta mag-ano. Let us calculate na lang. Okay. Wait. So, N is equals 25 divide 208.23 divide 2 over divide 2 wait lang 0.0 0.121 equivalents per liter. However, ang gipa-solve diri is milliequivalents. So we will use the conversion factor. 1 equivalents per liter is equals 1,000 milli-equivalents, mi-eq over liter, times 1 equivalents per liter kay 1,000 milli-equivalents per liter. So the answer for this one is 1,120.1 milli-equivalents per liter. Okay, next example. So how many milli-equivalents are in 1.0 liters of 4.5 normal HCl? So using your formula, N is equals weight of solute divide EW times the liters. So given ang ato ang normality, 4.5 equivalents per liter. Weight, so ang weight kay wala ta kabalo, weight equivalents divide weight equivalents, weight of solute in milli equivalents. So weight of solute, EW for this one, HCl 35.45 plus 1.01 36.46. So 36.46 gram per mole divide 1 equivalents per liter times ang liter niya is 1 liter. So cross multiply, weight of solute is equals 4.5 equivalents per liter times 36.46. Again kani ato ani siyang this is mole. Ato siyang i-simplify, cancel out the mole. So we have 36 gram per equivalents times 1 liter. Cancel out the liter, equivalents, so we have grams. So the weight of solute of sa grams is 164.025 grams HCl. So ang question kay milli equivalents. So again, to solve the equivalents, we will use the formula mass divide EW. So we have the mass kani 164.025 gram of HCl over EW 36.46 gram divide 1 equivalents per mole. Cancel out the mole. So we have real answer. And then cancel out the gram. So mabilin, equivalents. So 4.5 equivalents. But this is milli. So 1 equivalents is equals 1,000 milli equivalents. Multiply by the conversion factor. 1 equivalents, 1,000 milli equivalents is equals 4,500 milli equivalents. So this will be the answer.